Good morning, good afternoon, or good evening, wherever you are. Thank you for joining us today. My name is Mike Becerra, and I'm part of the marketing organization. A very warm welcome to today's webcast, Real Clouds, Fake Clouds, and Appliances, the Facts, the Myths, and Thuds for Enterprise Security. We are very fortunate to have a great speaker today, Patrick Foxoven, who is the VP and CTO of Emerging Technologies at Zscaler. Patrick is an experienced managed security executive, having spent more than 15 years building secure, scalable, and redundant internet-enabled networks. He owns multiple patents and has co-authored 3 books on information security. So, without any further ado, it gives me great pleasure to pass on to Patrick to actually kick things off. Patrick, over to you.
Thanks, Michael, and good morning, good afternoon, good evening to everyone as well. Let me start briefly with a quick agenda slide. I want to start with the first few minutes, just a few slides on kind of reviewing where our take is on the threat landscape today, before we get into talking about why we should even care about enterprise security or how to approach it with clouds or fake clouds or appliances. I want to kind of just highlight some of the things that we see from our perspective on why it's such a relevant discussion today. And then I'll spend the majority of the time going through and contrasting and comparing clouds versus fake clouds versus appliances, and what are the trade-offs and the pain points, and how do you contrast and compare these different solutions. You'll hear me call fake clouds as hybrid as well. With fake clouds can refer to anything that a vendor uses in the terms of hybrid when they apply it, or also in terms of a vendor that used to sell appliances that's trying to make a cloud to kind of capture both at the same time. And then I'll conclude with just 3 slides about Zscaler to give a quick overview just about the company, and then hopefully keep some time at the end, 10 minutes or more, for some good Q&A. Feel free to send questions along the way as I jump through the presentation, and we will circle back to them at the end and try to address all of them. So to start with the threat landscape, and obviously the new threat landscape, I don't think it's going to come to a surprise to anyone on the call, is all about mobility and cloud. But let me drill into that a little bit more. We spend a lot of time talking to. We have over 5,000 customers now globally. We see traffic from 183 countries every day through our cloud. So we've got a good visibility and a very diverse, globally aware customer base. And some of the stats that we end up seeing a lot, and this will mirror what you hear from analysts and other industry experts, is on the mobility front, we're seeing now as much as 90% of users are taking their laptops at home or on the go. We really don't have a concept even in Zscaler of fixed desktop PCs. All the employees are taking their laptops home and they're going with them wherever they go. And about half of those users have BYOD in some way. So whether it's their phone or their tablet, or sometimes even their laptops now, because users are bringing in MacBooks instead of corporate issued Windows laptops, or vice versa, et cetera. So mobility is here. We don't need to spend a lot of time drilling into it, but it's here and it's not going anywhere. From a cloud usage perspective, this is the space that we see exploding. I just came from the RSA conference this year, and by all means, this is here, and very much there's a lot of technology and companies spawning up trying to address this challenge, which is purely just getting visibility to what cloud apps are in use in a company, and then how do you start to control and put policy around them. And then the last piece on social, these are all building towards the fact that the internet is being used more and more, and we're seeing in a lot of companies the percentage of traffic now on their internal networks no longer being internally destined, meaning it's not traffic going to their own data centers, it's traffic leaving their network, going to the internet, going to social sites, or going to these cloud application sites as well. And that's why we're really seeing the security model that's been in play for the last 10, 15 years being kind of turned upside down. And the days, in my mind, of deploying appliances everywhere where you need to try to provide protection is becoming very ineffective, and I'll spend some time drilling into that. On the threat landscape as well, just to kind of contrast where we've seen the evolution of things in the last 10 years. From 2003, when you look at 2003 as one point of comparison to 2013, or practically today. We need to update this slide to 2014. But in the enterprise space, we saw things being very stationary. The workforce is PC and laptops, and they're at the corporate networks, and they're protected when they're there. And when they're remote, they fire up a VPN, and that's usually how they get the same level of protection. But when they don't fire up that VPN, they obviously don't have that protection, and it's primarily corporate-owned devices. And now we're seeing smartphones and tablets everywhere working from free Wi-Fi networks, and employees bringing in their own devices. From an attack perspective, or who's actually fueling the attacks, if you look 10 years ago, you see attackers are primarily motivated by challenges. There wasn't a lot of financial gain, and now they're obviously well-funded, well-organized. They could be even state-sponsored organizations, and there's massive amounts of financial and political gain. The attacks 10 years ago used to be very loud and noisy, and now they're quiet and stealthy. So everybody knows the terms advanced persistent threats and what modern threats look like today. But security, you see there's obviously the first three builds are very obvious on things were very stationary to being very mobile and not a lot of gain and tons of gain. But security 10 years ago was deploying URL filtering and antivirus. And today, unfortunately, we still see a lot of companies still saying that's the same type of security for a completely different landscape, different enterprise scenarios and network scenarios, different attackers and different attacks themselves. And as a result, it's pretty obvious URL filtering and antivirus is not the right technology to have in place today for this threat landscape. And so I'll spend some more time talking about that as well. Just to kind of really drill in on some of the challenges that I hear a lot when we're talking with our customers is this concept of invisibility, which is really another way of saying that the trusted network is disappearing in many ways. And I'll just drill into it just a little bit because these all have influencing factors on what solution do you look at selecting when you're looking at how to address this evolving threat landscape, whether it be a cloud or appliance or a mix of the both. So from an HQ perspective, often customers are faced with how do you consolidate data from different point products. So you'll see a stack of appliances that are doing all kinds of different features and functionality. One box to do AV, another box to do advanced threats or advanced persistent threats, another box to do firewalling, another box to do IPS, et cetera. And at the regional locations, 10 years ago, the way that you would protect them is make them backhaul their traffic back to these stack of appliances that are very expensive. And from a business point of view, when you look at acquiring or bringing in other entities within the network, they often will have incompatible technologies to that. And remote users is a huge pain point because the VPN is a poor user experience. I was just talking to a very large company yesterday, and they decided to say that the only way we can secure this is require users to VPN in whenever they need email, anytime, no matter what, and they have to force all their internet traffic to come in as well. And they have one location where it all comes into around the globe. So if you happen to be in Europe, you're going to have your traffic come back to the US before you can get out to the internet. And that's just a painful approach, and that won't stick around forever in my mind. And then cloud is causing the actual data that you're responsible for protecting is no longer within the HQ itself. It's everywhere. It's in these third parties and services. And this is just a high-level diagram illustrating all these different challenges that exist. And mobile complicates this because you're no longer in control of the devices that the users are bringing. So where's the line of how you manage and govern it? Visibility is huge because either these remote users are bypassing all this fortification with stacks of appliances, or the reporting itself between all these different disparate products is not consolidated, nor is the management of that policy or control. So I wanted to pick on, just to drill into the point further, how iOS is forcing enterprises to rethink this kind of security, just to further accentuate the fact that things like antivirus is not the right way to address these threats today. Yesterday it was perfectly fine, 10 years ago it was perfectly fine to deploy a piece of software on every device that had full system level access to do things like antivirus protection. Today on an iOS device, you cannot implement AV in that manner. There's just no way to do it, and I think that's a preview of what will continue to come in the future. In the past, when you had devices that were on network, you controlled that network activity, and now these devices also have 3G or LTE connectivity, and they can completely bypass all they don't have to be on your corporate Wi-Fi anymore when they're in their building or have access to your data. They can be connected to the internet through networks that you do not control anymore, which is a big change. One thing that is nice is that a lot of the traffic today is still HTTP-based, but it moved from being primarily browser-based to application-based. So it's not just about protecting the browser. We see solutions that are just around protecting browsers, and those are completely American in a world where a lot of this traffic is coming from apps that aren't even browsers themselves. DLP is still huge, and who owns it we've touched on before as well. But we're really seeing this is what's everybody's concerned about in the whole industry. And so is the traditional network of hub and spokes and deploying stacks of appliances, is that the right approach to address all of these things that have really changed and been turned upside down in the last 10 or 15 years? My answer obviously is no. You need to rethink and re-architect how you do this. And so that's why companies are looking more and more towards the cloud or hybrid approaches, because I don't think anyone will argue that the pain points of having appliances only in a certain area of the network and users only protected when they're behind them. And how do you deal with the worlds where the users are everywhere and connecting from everywhere, and you don't want to slow them down or cause the pain point of having them have to send the traffic back behind that stack of appliances. That's just not working anymore. So let me spend some time talking about it. We've been I've used Zscaler as being the longest pure play cloud provider in the security as a service space. We started day one from never selling a box or a piece of software license. And we had the luxury then of designing our solution from scratch to be a cloud delivered enabled solution. And we really don't see any other company, this won't, in my mind, won't always be the case, but we don't see any other company today that's a pure play cloud provider. But we do see a lot of companies, cloud is without a doubt becoming the accepted way to do these kinds of things, especially in a security as a service space where you're only sending outbound internet traffic to us. We're not sending, the type of service that we provide, you're not trusting us with confidential data or databases or email or other things that you need to be a little bit more concerned about trusting the cloud. You're only sending us outbound internet traffic. So it's a very easy fit even today as the cloud technology and space matures. Even today, it's an easy fit to use a cloud service to provide outbound internet or user level security for browsing the internet. And so without a doubt, I think that's becoming more accepted in the industry. And as a result, we see a lot of the traditional incumbent players that either made the appliances that have been sold for the last 10 or 15 years, or they made the software, want to jump on that cloud bandwagon. And we kind of see them doing it in one of two ways. They end up either saying, we're not going to fully embrace cloud because we've been doing this appliance or software-based approach for the last 10 or 15 years. We just can't do that. We can't change that quickly. So they're introducing this new term called hybrid, which causes a lot of confusion and is very disjointed. I'll spend a lot of time talking about that. Or they're saying we are going to create a full cloud. We're not going to require you to have our boxes or do interconnectivity between our old 10-year-old appliances and this new modern cloud. But they're doing so in ways that they take a lot of shortcuts. And I'll help walk through some of the really easily identifiable questions that you can ask to see, did they build a real cloud or a fake cloud? Because we still don't see the right investment to build a real cloud, to build it the way a company that has real clouds, I'd pick on a company like a Google or an Amazon, they have very real clouds. They build real infrastructure and real technology, real multi-tenancy in ways that if somebody wanted to become the next Amazon or the next Google, they would not do so by racking and stacking a bunch of servers in a data center and not doing any integration between that site and other sites and calling that a cloud. And so I'll spend a lot of time contrasting and comparing these kind of three technologies, a real cloud versus hybrid versus appliances, and which ones are fake clouds and which ones are real. So the first 5 slides, I'm just going to touch on some broad comparisons between, we've got Zscaler here as the header, but you can also akin it to what I would consider a real cloud. This doesn't have to be just a vendor-specific pitch for Zscaler. This is any real cloud. And how do you weigh if the solution you have is going to be real? So from an operational point of view, and I'll talk on these 5 things, and then I'm going to drill in more specifically and talk about some of the pain points and contrast and compare as well. So on in a real cloud, you really should not, in this model, you shouldn't require any hardware or software. If companies require you to install software or hardware on your premise, that means they're either stitching together a legacy solution that previously relied on those appliances being on premise, or they built the cloud architecture such that it's not modern. There's no reason why you would have to require software to authenticate a user on the way to the internet. Can you imagine if you were going to a guest hotspot in a hotel and they would require you to install a piece of software before they allow you to go out to the internet? That's actually still what a lot of companies today that are legacy are still requiring on their end users, is to install software, install these other components to try to guess who the user is. And that's not a key tenet of a key mark of a real cloud. You obviously have to have built-in high availability and service level agreements. Service level agreements beyond in a real cloud, if they're doing things right, the SLA should be way more than just if you're up and down. The SLA should be around how well it's performing, what's the efficacy of the services that are being provided. It should be way broader than just, we're available or how many nines is it. A real cloud has to be elastic and scalable, which in essence is meaning that if I need to take on new capacity or deploy additional functionality in my cloud, it's not a model of having to upgrade every customer to be able to take advantage of that. There shouldn't be any concept of marrying a customer to a specific data center or a specific set of services. That customer should be on the cloud itself, on the service itself. And as new capacity gets deployed, everyone takes advantage of that day one. There's no re-provisioning or rejiggering how to allow customers to use that new capacity. That's a kind of a key differentiator that we see a lot. Is one standalone question is you can ask is, am I married or am I required to go through this data center or this specific site, or can I go through any site at any time and there's no difference in the type of service that I receive? So I'll drill on that a little bit more in a few slides as well. In a hybrid model, there's no way around it. When you have hybrid, that means you're marrying on-premise appliances and in the cloud or hosted services that company's provided. And as a result, I still have not seen a hybrid solution today that provides a single console that does everything that you need to do for the service. Hybrid is almost always meaning you're going to have a UI on the end of clients to do certain things. You're going to have a UI on the service as well. And as a result, sometimes that means there's different sets of policies and configurations, and you don't get the true benefits, in my mind, of what a real cloud solution would be, which is you don't have to have multiple management consoles. You can have a single console that applies to the service as a whole. And then obviously appliances, it goes without saying you're maintaining that hardware and software. There's deployment challenges, and it's not elastic, meaning you need more capacity. We spent a lot of time talking with customers that were doing SSL inspection as an example. And just this last December, certificates across the board, industry-wide, moved from 1024-bit in depth, or in how cryptographically strong they are, to 2048-bit. That's actually, if you look at CPUs today, that's about a 5x performance difference. And so literally customers were saying, if we need to continue to do SSL inspection come January 1st, the only way we're going to be able to do it is we need to deploy 5 times the number of boxes. That's not scalable. In my mind, a real cloud, one of the real benefits to end users of that cloud is that cloud provider has deployed infrastructure at scale. And so they've captured economies of scale, and being able to absorb huge performance changes for different scenarios should be a no-brainer. It should just happen. It should never be a concern to the end user. And obviously that's what I mean by appliances are not elastic. Another key area to look at to contrast and compare is visibility. So in my mind, a true cloud in a solution that is security and that is providing visibility and control around where everyone's going on the internet in a security as a service model. From a visibility standpoint, that should be real time. It should not mean come back to us in an hour or 24 hours to get the data that you want. And analytics, meaning being able to pivot on that data and understand it in a more intelligent way beyond just the data seeing a bar or pie chart, in my mind, is not good enough. There's no way you're going to ever uncover not even an advanced threat, a moderately advanced or somewhat advanced threat, you're not going to uncover, be able to have insights to that unless you can pivot and do real analytics on the data itself. The days of a static report are gone, and the companies, the fake clouds that don't give you that kind of rich analytics, they either obviously haven't invested, but often the reason why they don't is they're taking the same reporting technology that was in place for a single company, and they're trying to extend it to be in place for many companies or for a multi-tenant model. And as a result, it's very hard. If you built that to address one area, which is a single company, and then you're trying to morph it into being able to address a big, massive, scalable cloud, it's very hard to allow you to pivot and sort that data and do things that are computationally intensive. And as a result, they just don't give that functionality. So that's another key thing to observe is if you're getting a fake cloud or not, is there rich analytics? Is there ways of interacting with that data? And I'll take that to one step further. Is there any way that you can get that data out of that cloud back into your environment? So let's say you want to do event correlation across security information platforms and other tools. Can you get the data out of the cloud? And the companies that have fake clouds, they didn't invest in scenarios like that because those things weren't relevant in their previous model of a single company solution. And so that's a key tenet of a real cloud. With hybrid, you have to consolidate the logs. It's fundamentally part of the solution. You've got a box that's on your prem, and you got another service that's in the cloud. And the hybrid concept is marrying the two. That means you got to marry the logs somehow. And so you have to, depending on the hybrid solution, you got to figure out how those logs are going to get consolidated. Some hybrid solutions I've seen, you have to actually do that consolidation yourself. And I'll touch on that a little bit later on. And then appliances, they're standalone appliances that give you localized views of specific sites or locations at a time. And if you want to consolidate that, you have to either buy very expensive central management solutions that are very painful. They often don't do everything. They're definitely not as integrated as a real cloud solution. And it's really up to you to be able to do that consolidation and to be able to even just simply get a report that gives you a view across the organization, let alone how do you manage policies across all those different devices. From a total cost of ownership, whether it be CapEx or OpEx, in a real cloud, you should not, again, if it's a real cloud, going back to my first point on the first slide, you shouldn't require any hardware or software at all. So there's huge amounts of CapEx savings because you don't need to be buying these racks and deploying additional boxes. You should be, from an OpEx standpoint, be able to reduce your management a lot. Now, I'm not saying you need to get rid of the people that were managing all of the other complex stacks of appliances, but what you can do is refocus them and allow them to work on what matters the most, which is the policy itself, which is understanding and taking action on the analytics and the reporting and the data that becomes available, not letting them or not having them focus on where's the next box needs to be deployed or upgraded. And in a true cloud solution, if the cloud is really elastic and scalable, that inherently means it's available anywhere. It should be anywhere around the globe. And as a result, we see a lot of customers that when I was talking about the threat landscape, the days of backhauling this traffic doesn't have to happen anymore. And as a result, we're seeing real customers get real savings on MPLS backhaul because they no longer have to backhaul the internet back to HQ behind the stack of appliances. They can let it break out at the branches locally, go direct to the internet without losing the ability to have security policy and visibility on it. In a hybrid solution, obviously it's hybrid, so you're going to have CapEx and OpEx because you're going to be buying some boxes and some services. And from an OpEx standpoint, you are going to have to maintain the boxes that you do buy. Those are boxes in your network on your environment. So it's not as easy of a TCO calculation in a pure cloud solution. And then you also have to do some training because there's more complexity. It's not just administering the policy in a true cloud solution. It's also managing your on-premise devices and all the things that go around that. In appliances, you still have the deployment challenges. You still have the appliances are only as good as the traffic that they see, and so there's very rarely a situation where you can deploy appliances everywhere, especially when you're talking about having a user go home. You're not going to ship a stack of next-gen firewalls and APT appliances to every user at their home. So how do you still provide an equivalent level of protection to them well, you start thinking about how to backhaul it or force them to VPN and then slowly to their network in other ways. Two more kind of comparisons. User experience. The true hallmark of a cloud is it should be, again, like I mentioned on the previous slide, it should be available everywhere. And so the user experience should often get much better in a true cloud solution, meaning the user gets the capability of having their traffic processed by whichever data center or whichever service they are around the globe. If you think about that from a perspective of how companies like Akamai, as an example, have built how do you deliver video and how do you do content caching and delivery and make high bandwidth applications work on the internet. They do that by making sure that if you're watching a video, you're always getting routed to the closest point of presence or the closest node on their network. And so if you're in LA today, you're going to get an LA set of streaming servers giving you that video. And if you get on a plane and fly to Tokyo tomorrow, you're not going to be getting your video from LA. You're going to be getting your video from Tokyo. And that's the concept. A real cloud that's providing a security as a service should be doing the exact same thing. The policy should follow that user wherever they go. And as a result, you really can eliminate backhaul and improve the user experience. Even though fundamentally you're saying I'm sending all my traffic through an extra hop along the way to the internet, but I guarantee it's much better than a hybrid or a appliance-based approach, because the cloud is going to be built out way more in a larger capacity than a traditional on-prem solution would be. Hybrids. So often hybrids don't have wide coverage because the hybrid nature means you got boxes in your network, and you need to look at how many places where those boxes are, and then determine which users are going through which boxes. Or sometimes we see hybrid, meaning the boxes are on-prem in the customer's physical location, and then when the employees go home, they're going through the service piece or the pseudo cloud service. And what ends up happening is that company is supporting both. They're still making hardware and boxes and processors and all the different pieces of functionality that goes into an appliance, and they're trying to build a cloud service. And there's no way they're ever going to capture the economies of scale if you're just worried about managing and operating a single cloud. From an appliance standpoint, you're still backhauling the traffic, and roaming users still have to VPN in. So the user experience is terrible. The company that I mentioned that I spoke with yesterday that had a single breakout across the globe, it's so painful that because they have a security policy that says when you're VPN'd in, all internet traffic has to come in so that we can inspect it. They don't allow split tunneling or breakout even on remote users. What their employees are actually doing is downloading VMware and virtualization software that is creating a guest Windows VM to then create the VPN in that VM so that they can get their email and not have the internet and the rest of the system slow down because of how they're trying to get to the internet for other traffic. It's just crazy. This approach of trying to stitch together the VPNs, I don't think will be around much longer, especially as bandwidth continues to increase, cloud apps increase. This stuff should not be backhauled. So what are some of the key pain points that we hear a lot when you're comparing appliances and hybrids and real clouds together? And I'll touch on them in a couple key points. So the first one I'm going to pick on is security concerns for a traditional appliance vendor. So fundamentally, when you're deploying an appliance to do a security function, you don't have the same economies of scale or distributed infrastructure that a real cloud solution would have. And so as a result, you're forced to operate within the constraints of what that one box can do. Sure, you can cluster together multiple boxes and that can extend it a little bit. But as a result, doing a lot of things is very hard because you'll end up exceeding the resources that one box can have. Whereas in a real cloud solution, if your traffic is going through a particular data center, that cloud provider can deploy infrastructure at scale to do many different things along the way. And it can be distributed. It doesn't have to all live within the constraints of an appliance. And so what we see with traditional appliance vendors is they don't turn on full inspection of all traffic coming in and out of the box because that's painful. In fact, some of these vendors will give you warnings if you try to turn it on, saying, "Hey, your performance be cut by X percentage," and usually X is multiples. That's exponentially different. And so simple things like a key way to test this is take a piece of malware. It can be a test virus, as an example. It doesn't have to be live malware. I'm not advocating accidentally infecting anyone. Take a piece of malware and host it on your personal blog. And your personal blog is likely going to be considered trusted. See if you can download that from your personal blog. And that technology of allowing good, reputable sites, the only reason why it's there is because you have the performance constraints of living within the realm of the box. And you don't have that in a true cloud solution. A true cloud solution should be able to scan and do all of the security all the time without having to bypass things from performance point of views. In a typical appliance scenario, you can't really do aggressive analysis because you're not going to no appliance does full analytics and reporting or trending on the same box. You got to get those logs off somehow and bring it into another product that can do things like that. And again, the other piece with the appliances is they give you a single view. They're based on static URLs, and they're only good as their last update. And that's technology just like AV. It's not any different. AV is blocking what's known good blocking what's known bad, and then allowing everything else, thinking that it's good, and it's only as good as its last update. The same thing applies for these URL filtering appliances. In a hybrid vendor, obviously you have to keep the local system up to date, but then it's only as good as when it's connected to the hybrid cloud itself. So what happens if it can't connect? It can't get policies. There's a lot of downsides to when that actually happens. There's often in a hybrid solution, there's no advanced threat functionality because there's an inherent challenge of integrating something on-prem and off-prem, and you're marrying two technologies together, and that's a hard enough problem in and of itself. So how can you think about starting to enhance that hybrid capability to do the real advanced things like being able to do behavioral analysis and detonate pieces of software take pieces of software and put them in detonation chambers to see what happens, and do some more modern ways of looking for threats and doing analysis. And authentication in a hybrid scenario is also equally challenging because often you may have authentication happening at the appliance level and then a different way to authenticate happening outside in the service level because you're stitching together two solutions. And how do you tie authentication and share that? In the cloud design, in a typical hybrid vendor, again, this is getting to real versus fake. We see most pseudo clouds or what are being marketed as clouds as not having true redundancy or resiliency, meaning they're marrying users to towers or stacks of equipment, and they may give you a primary stack and then a secondary stack, but by no means are you able to send your traffic through any one of their sites. So they show you a map with, may have 20 or 30 dots on it, but when you become a customer, you're only able to go through one or two or maybe three of those dots, and it's a big challenge. There's no real multi-tenancy, and again, I like to compare that to something like Akamai or Content Delivery Network. CDN solved this challenge 10 years ago, but I haven't seen a company yet that has taken that same approach to a security as a service delivered model and solved it in the same way, which is the right way to do it when you build a real cloud. The only reason why they're not solving it is because they haven't built a real cloud. It's a harder problem to solve. In a fake cloud, we often see, ask them, another way to know if you're going to a fake cloud is ask them to drill a little bit deeper into their architecture. It's very important. I would say this generically across adopting any cloud application, is you can't, the days of saying trust us it'll work or trust us it's good or trust us it's secure is not good enough. The onus is fundamentally on you to ask a little bit more questions and understand, either where your data is or in this case, what's the architecture of how you're getting served. And a very key hallmark of a cloud that is fake or a pseudo cloud is they're literally taking the same types of boxes that you had in your network. So as an example, your proxies, your AV inspection devices, your IPSs, your F5 load balancers, they're taking that same stack of equipment and they're putting it in their data center and they're calling it a cloud. They may be deploying bigger boxes so that they can get more performance out of it, but that's all they're doing fundamentally. And that is completely a fake cloud because then what happens, again, when your traffic goes to another data center, they have the same challenges that you had. How do you make sure that you as a company exist on that second data center? And if they didn't invest in the right things to make this be scalable and elastic, and they're becoming, the fake clouds are becoming just a giant MSSP. It's just an evolution of what ASP was or managed services was. It just happens to be that the boxes are in their data center versus yours, and that's not a real cloud. If Amazon and what they do in their Amazon Web Services would never be nearly as successful as they are today if that's all that they were doing. They spent real time and invested real IP and did real development around how do you build a platform that is scalable, that you as a customer can deploy your services on any site at any time on demand, and there's no involving anyone. And that's another key hallmark is, and we get questions asked is, if we're providing a security as a service from the cloud, how long does it take to make a change? If the answer is you got to open up a trouble ticket with the provider and wait for them to respond and make the change, it's not a real cloud, because what they're doing behind the scenes is they're integrating these disjointed, disparate systems, and that's why they're making the change for you. If it's a real cloud, you should be able to log into a web panel, make the change yourself, and activate it yourself, and it should happen instantly. There should be no delay. There's no reason why today, with modern technology, there should be a delay when you're applying your policy. It should happen on the very next transaction immediately. If it doesn't, they're stitching together something, or there's something behind the scenes that's not making it be a real cloud. They're waiting for some central management system to deploy the policy across the nodes individually, and you just have tons of challenges with that. So that's another key question to ask if you're trying to figure out if you have a real or fake cloud. We see the appliance vendors and the fake cloud solutions taking an approach like, this is a good way to illustrate in real world. Let's say we were providing power. Power was the utility that we wanted versus security. And the power generator approach is when you need a bigger data center or the bigger office, you deploy more power generators. When it's a smaller site, you deploy less. And if you compare this to what a real cloud should be and what a real cloud has done, the real cloud should have built a power plant, which is, in essence, there is no concept of marrying a stack of appliance or power generators to a specific organization. And everyone should be able to take advantage of that scale and that elasticity at any time. So if more power is required in one particular area versus another, there's nothing that has to happen. There's no such concept of stacking another 10 power generators in front of that one site. And when that site's not using that capacity, then it's just idling. The cloud should be elastic in nature. In an appliance vendor, going back to some of the pain points in reporting and logging, and as well as this often is applied to hybrid as well, you gotta bring the logs or consolidate the logs somewhere, and that's often done by having to FTP it, having a separate log server to store or to receive those FTP logs. Often there's a different database completely for doing offline analysis or even deeper analysis, and as a result, there's no way you're going to get real-time functionality if you have to FTP logs from 50 different boxes around the globe. And that's a real pain point that we see. Customers will look at adopting a real cloud solution just to solve this challenge, which is how do I get central visibility and not have to have all these logs be consolidated or transferred into some system on my own. And that's a key tenet of a real cloud as well, is that you should never even have to think about the logs. Logs should never even be a part of the equation. You may, from a security or compliance standpoint, care about where the logs are stored. That's very relevant in a cloud, because you may want to make sure that logs in the EU get stored in the EU and not in the US, or vice versa. But you should never have to worry about where am I going to send these logs or how am I going to consolidate them. That should just be an inherent part of the service. If you think about the days of Gmail, you should never be thinking about how you're going to store all this mail. The storage is just an inherent part of the service. But what's crazy is in the enterprise security space, in these hybrid and fake cloud scenarios, where the logs are still come into the equation often, in terms of not where they're stored from a compliance standpoint, but how they're actually getting consolidated in a hybrid model, as an example. Because you gotta get the logs from the hybrid appliance into the service itself. That's the pseudo cloud side, and that becomes a big challenge. In terms of total cost of ownership, when you're comparing hybrids and appliance vendors, often a hallmark of a fake cloud is they're charging per IP instead of per user because they don't have a way to elegantly authenticate the user, or if there's two interfaces to the service, it's not a real cloud. Meaning, if there's one web UI to do one thing and another web UI to do another thing, it's not a real cloud because they're marrying together two disjointed solutions. If there's any concern or discussion around how things get updated, especially from a security point of view, you're only as good as your last update. It's likely not a real cloud. The real cloud should be taking the updates inherently as a part of the service. We're deploying hundreds of updates every single day, and it's a non-event. The customers never have to worry about it. If you're ever having to manage your own software lifecycle, deploying your own software, or when do you upgrade, it's not a real cloud. And if there's additional software and licensing to do things like SSL inspection or other things that the cloud should be doing at scale, if it was designed right from the beginning, it's not a real cloud as well. If you require separate boxes in a hybrid scenario to do other things beyond just, let's say you're doing URL filtering and you want to add on DLP for data that's in transit to the internet, or you want to add on advanced security and do things like behavioral analysis. If you have to deploy an additional box, it's definitely not real. And that extends to if every location requires the same thing. You have a crazy amount of complexity if you have to expand that out to many sites. If there's if there's a central management box, so if you have to deploy boxes that are the service box, and then you have to deploy another box that's a central management box that may interface with the cloud itself, you're stitching together disjointed solutions that were never really meant to be there. That's why they're making it as a separate box. And in a hybrid scenario, a real big pain point is capacity planning still. The real benefit of a cloud is send your traffic to the cloud and never worry about the capacity on the other side. But in a hybrid scenario, you still have to worry about the capacity on your side as well, which really challenges the TCO. And a user experience, again, if it's not a real cloud, they're going to have likely limited data centers, or if they show a map with lots of data centers, you're only going to be able to go through a select few. That often means the solution's not multi-tenant, and they're marrying you to specific data centers. The other piece or pain point that we hear a lot of FUD around is caching, and that's why some vendors are saying hybrid is the way to go because you want caching capability. And really, what we're seeing today is caching is not relevant anymore for modern web content that is so dynamic, and you have content like Ajax and other things that caching really doesn't have a benefit. We're seeing cache hit rates be irrelevant now, and the cost of bandwidth now is so low as well that maybe you're getting 10 or 20% cache hit rates, but is that worth all the pain of caching? And is it worth even having those boxes around anymore if the cost of just upgrading the bandwidth pipe by 10 or 20% is so minimal? So just to give you an illustration, this is what we see the fake clouds of the world or appliance solutions of the world looking like. They have very, very poor coverage, and there's always latency because users are having to backhaul traffic to certain locations. And really, to give you a little bit of a lead-in on what we've built, and this is actually our production map today, a real cloud should have coverage everywhere. The map should be lit up all over the board, and the user can go through any one of these sites at any time without limits or without restriction in the level of service that they receive. And so let me give you 3 quick slides about Zscaler. So we recognized these challenges when we started, a little over 6 years ago, that mobility and cloud applications were going to be turning this threat landscape upside down. And I don't think even the vendors that are still trying to pitch you hybrid or their fake clouds, I don't think anyone would disagree that the cloud is really a good way to address user-level security as these users go to the internet, just fundamentally by the fact that the users are everywhere, they're on all kinds of devices, and the data is the data is transitioning to being the majority in a company data center or in a corporate HQ to being, in cloud-enabled services, whether it's Office 365 or Google Apps or other services. And so what we thought very big, and what we decided to do was to build a technology from scratch that wasn't based on, again, legacy software or appliances that would go on a customer prem. Build that technology to be truly cloud-based and be truly distributed, and in a way that we could distribute it all over the world without compromise. So if we wanted to add 50 or 100 data centers, we actually financially could do so, because we're not deploying, stacks and stacks of all these different appliances. There's ways to approach an architecture like this, not unlike what the CDNs of the world like Akamai did 10 years ago. That's what you have to do in this space. And so that's fundamentally what we did, and we can leverage this elasticity and this distributed footprint to do a lot of functionality. So it's really more of a platform play. You can buy it just to do one particular piece of service, meaning you can buy it just to do URL filtering or do it just to do things like bandwidth control. But because we have this big distributed network and we've captured multiple economies of scale, and we built the technology from scratch, we're not trying to put together disjointed solutions. We can do a lot of functionality, and we kind of break it into 4 buckets. We start with security, and security is way more than just URL filtering or looking at URLs or allowing things that are reputable, known bad or known good. We need, from security, we need advanced threats, which is inspecting every packet that posts to the network bidirectionally in real time, which is taking executables that we think are good and running them through behavioral analysis at scale, doing that in the entire cloud itself and putting them in the detonation chambers and seeing what happens. It's integrating threat feeds from dozens of security partners, whether it's Google or Microsoft and others. And we do AV. AV antivirus is table stakes. Often it's still a checkbox. But to touch on my very first slide, where AV is not good enough, it's what was developed for 10 years ago. AV is only responsible for about 3% of the total security blocks in our cloud on a daily basis. So it's still there. It provides a little bit of protection. We have it, but it's not relevant. The real focus is on advanced threats. It's blocking 97% of the other security blocks that we see in our cloud every day. On the control front, traditional URL filtering, still lots of organizations need to do that from a liability perspective. But we see a lot of customers wanting to take that to the next level, which is get more granular than just allowing certain URLs. They want to say, I want to control specific cloud apps. So I want to allow a user to go to Facebook as an example, but not allow them to post during business hours. Or I want to allow them to use web instant messaging, but not allow them to send a file attachment. Or purely just have visibility and not just look at URL categories, but look at cloud apps as well. That's a fundamental part of the service. We can do, in streamlining WAN, we can do local internet breakout, like I talked to before. You don't have to backhaul this traffic to get the level of security or visibility to it. We also can do bandwidth prioritization. So we can say that a user is no longer allowed to go to, you can say they're allowed to go to YouTube, but let's say during times of bandwidth contention, when let's say a critical business app like Office 365 needs bandwidth, the user may not be able to stream a video at HD resolution. They're going to stream it at standard def as an alternative. We do that very transparently. And under protecting data, we have a data loss prevention solution that is for data that's in transit to the internet. It's not a full-blown solution that, when you say DLP, it can mean a lot of things to a lot of different people. We're not saying we're going to index all your databases and all your file shares and do data protection for data that's at rest, but we absolutely will able to do data protection around data that's in transit to the internet to make sure that a user is 3 clicks away from going to Gmail, attaching a file of whatever confidential nature and hitting send. And that user can do that not just when they're at your office, when they're behind your DLP solution that's on-prem, but they can do that when they go home, and we still can provide that layer of protection following that user wherever they go. So this is fundamentally the services that we provide. The only way a real cloud can do these kinds of services is to build a lot of technology. And so the platform that we've built, that we spent the first few years in stealth mode and over 60 patents now around the real technology that we had to build, there's no way you can do this as a real cloud unless you build this technology from scratch. Any kind of marrying or taking the same appliances that were on your prem and making them bigger and hosting them will not be able to accomplish this kind of feature and functionality. And as a result, because we built this technology and we knew we needed to be distributed, We distributed it at scale. We're operating in over 100 data centers, half of which are available for any customer to use. Here, that's the map that I'm showing here. Is our public data center footprint.
Thank you very much, Patrick. That was great. I'd like to thank Patrick for hosting this. For next steps, there are a number of things you can do. If you're interested in seeing a real free trial, you can register at the link above. Secondly, you can also register to receive personalized demos from us. This is very, very easy to do. Just register there. We'll get back in touch with you and actually take you through a personalized demo. Or alternatively as well, we have weekly demos where we run through a high-level overview of the product.